Yeah, good evening all. As Raghav introduced me, I'm Shivendra Jadhav and I had R&D team and software efforts at Qualitas Technology. I'm going to quickly take you through a high-level overview of uh, uh, our cloud
Okay,
application.
here you can see this is the dashboard of our application, and here you can manage to see all the projects at once and all. You can add new project, you can add new user. A couple of points regarding security and role-based access for it. I am a member of Qualitas development team, so I'm a super user. So I can look at all projects, I can use it all this. But you can see that there are some well-defined roles which allow graded access to all projects. If you are a project manager, then you can do all things related to a project, but you will not be able to see the other project. If you are a labeler, then you can only annotate images. If you are a verifier, you can only verify images. And I will go into a bit more detail when we come up to the relevant part in the flow. But the idea is that you should not have access to data you don't need access to, or you should not have access to. So if you are a say a partner and you upload your project into it, you are able to add multiple people, even freelancers as labelers and verifiers, but they will be only able to label and verify, not look at other data, not launch any training, not look at your train model, which is your most important project related IP, or have any improper unauthorized access to. So I hope that is a good point to begin with. And then we go quick dive into the kind of application that Raghav has already built the context for. This is a project configuration. Here we specify what component we are inspecting, what class, what is the configuration, the number of cameras, and effectively what is the observations we are looking to get. That is the staplet bend defective or not, top ring cut defective or not, body defect with body dent or bottom ring cut or not. The idea is to completely specify all the input and output parameters, and believe me, that helps a lot later. For example, one of the practical challenges in machine vision solutioning is keeping track of data, what you plan for, what you've collected for, and what you're actually ingesting for. And this dynamic data collection plan, which is, as you observe, driven by the project configuration based on what outputs and what classes and what variants are related to what cameras, it allows us to completely have visibility into what was the data plan versus what was the data collected and what we have actually ingested. And believe me, during machine vision solutioning, there is nothing more important than keeping track of data. Are you collecting the right one? Are you labeling the right one? Are you training on the right one? Where are we in the process? Because that has a direct impact on your our solution timing. If you can quickly get the relevant data, very well and good. If you misestimate the kind of data, the quantum of data, then the project will get on hold and you will have to repeatedly indulge in the costly exercise of data collection, because that requires stopping on the line and quite a lot of activities on the premises, which is obviously always a time consuming activity. Okay, so this helps you avoid it. The third part when we come to it is labeling. Labeling implies, as Raghav stated, that this all machine learning based system learn on how we label the images. So if I label the images that hmm, yeah, something is present. I think I updated the ground truth of the image just now, that there is a defect present here. And I'm gonna label it like this. That means, say for example, this is a body dent. And then I save the label. Congratulations, we just labeled our training data. But as he pointed out, data is very important. So not just labeling, but an additional step in data preparation, what we at Qualitas call verification, where we verify, hey, whether the images that we have just labeled are they correct or not. And here again, the role of the labeler and verifier comes into much more relevant, because you see what we have found out from our experience is a person who labels should not verify his own labeled images. So here we actually keep track of who has labeled what image, and we do not allow you to label what image to label what image you have verified and vice versa. For example, if I look at this image labeled by Shruti, not yet verified. So when I go to verification, I am only allowed to see the images for verification when I click under this unverified is what I have not labeled. If I label, I cannot verify. If I verify, I cannot label. Believe me, it is a very simple concept, but it plays a very huge role in making sure our data preparation quality is very high right up front and the mistakes are cut down. So yeah, here I am satisfied with the label. So verify all, verify. My image is verified. But here I'm not satisfied. Maybe I don't like how the labeling is a bit patchy here. It is not crisp enough. So I mark it for correction and I add a note here saying that labeling not crisp. So what will happen is that this image is marked for correction. And when I go to labeling, you remember there was a filter here, mark for correction. And this image will come here. There's a correct camera that I'll have to involve here. But here, I am able to ensure that all the images that are verified have a very, very high chance of being correctly labeled so that when my model is trained, it trains on good enough data. The model may still be not as performative, but at least we will rule out the very tedious possibility of there is some mistake being in data preparation. And therefore, when we go to the next part of training, here we can add a training job. Here we can add which kind of model we want to. And here again, only that kind of models you are shown in this list, which allows you to address the problem up front. For example, this is a staplet pen. This is a classification kind of problem. So we show you only classification type of model. And I hope you will notice here that you don't have to type a single line of code to take the latest and the best performing deep learning models. Because one of the major reasons of QEP Cloud was to develop it as a no code platform for machine vision solutioning, where people do not need to have very deep knowledge of deep learning to begin machine vision solutioning. And here is how we allow you to work on the latest trained architecture of doing everything that you needed to write, say, so many lines of code before, and you are able to do it. So with this, just this, you can add a training job, and you can then launch into training. I would end my screen here. Hiren, can you share the screen from your end? Hiren? Hiren is not allowed to share a screen. Tanmay, can you please have a look at it quickly? Yeah, now here. So here we are at a training job here. So when the training is done, we are now able to see, yeah, it is done successfully. And then we can go to our model evaluation phase. Click on evaluation. So there are two steps to this evaluation. The first one is the matrix, and it is of more use for us, the software developers, because it allows us to see how model performance is looking like. Please keep scrolling down here. The data distribution, the losses, and all the confusion metrics as to what is correctly classified, what is not correctly classified, what is the mean IOU, and other relevant terms. That is for software development. Now, the more important and interesting will be for you is the visualization part, which allows you to see at a glance how my model is performing. This is the test data set. Click upon an image, please, here. Yeah, and here I believe you can see compare predicted to actual. Can you click on actual, please, here? Yeah, you can see how closely it is telling in both body defect as well as the bottom ring cut, which is the kind of body defect here. We have dent and the bottom ring cut. So predicted versus actual, you are able to quickly see, hey, my model is really, really performing well, or hey, my model is completely out of the base. And this helps you convey information not only to yourself, but also to your customer. Because rather than all the metrics and confusions and all that, in the report, I believe it will be more impactful if you just share a headline number of accuracy, which we gave, and this visualization. Click on another image, please, Kiran. Yeah, you can do it anywhere, for all the test data set if you have the patience to scroll through or you just want to look at the relevant highlight. We'll be actually building even more filters here regarding okay, not okay, and based on variant 1 and variant 2 and all. This is still a bit of a work in progress, but I believe this is sufficient enough to highlight how quickly you are able to drill down to the most basic question of, hey, is my model performance improvement or not? So over to the next step, Kiran, grading, please. And grading is what we have determined as a way to address persistent customer complaints. You just heard me mention the word accuracy. how to define a machine vision system's accuracy outside of a very set piece activities like UAT or FAT or whatever. What we have come up with the idea is that we take a subset of the images that have been inferred on the line. That is, the machine vision system has made judgment on these images and upload them back to our Qualitas web application and put them in the grading flow. Now, in the grading flow, we can apply a set of filters like what kind of model we want to grade upon, what is the camera I want to get my judgment on, what is the variant, and more importantly, what is the date I want to judge on. And here you can see all the dates that have data in it are highlighted separately. Here, continue. And here it shows the image. In the image, I'm predicting a bottom ring cut. And here, yeah, there is a bottom ring cut that you can notice, observe here, right? Which means my grading value is should be bottom ring cut, and my machine vision system is correct. That is the inspection result of the failure of the cylinder is actually correct. Now imagine doing this for 50 images, say 3 times a week. Now over a month, what kind of data you will have generated? Let's have a look. Grading report, please, Siren. Yeah, again, in the grading report, you can again set up multiple parameters. For example, I want to grade for month of February. I want to grade for the output. I want to grade for all the cameras. And I want to grade for all the variants, domestic versus cylinder. Remember? Right up front. And here is my inspection summary. For example, there were 40 inspections, 3/4 correct, 1/4 wrong. These were the numbers coming in stay plate bend and top ring cut and the body defect of dent and bottom ring. These are the, by the way, these are the total ground truth present, out of which how many we have okay and how many we have not okay. So we have individual accuracy at the model level itself. Go down, please, Hiren. You can also get a very good summary in terms of both the models, as you can say for stay plate, for top ring cut and body defect. You can get in terms of count and percentages. And you can get into in terms of models and observations. Yeah, please click on that. So as you can see, you can look at in terms of individually how many are good out of good, bad out of bad, and you can look in terms of entire model accuracy also. And last but definitely not the least, please shift on to the spider chart version. You can get a very good representation of the summary for all the variants we have. Now, this is only two variants, so it may not make too much sense here. But imagine if there were 5 types of cylinders, and you are very desirous of seeing how hey how are my models doing in each variant overall in terms of each of the defects. So here is where this type of chart will quickly allow you to determine, hey, maybe my commercial part is going well in this, but not here. And maybe my domestic lenders are doing it for this defect, but not for this. And these are the kind of insights which will help you drive very two important things. First of all, confidence in the accuracy of a machine vision system. When you do it repeatedly with a human in the loop, then you get, when you say 95% accuracy, you will have enough to prove to your client, yeah, this is 95% accuracy. And number two, how to get it to the next level of accuracy. Because when you do grading like this, you get insight into what model is working, why it is not working. And when you look at the graded images, there is an option to feed all the NOK images that a human in the loop has rejected our machine vision system judgment directly to the training. The idea is that rather than training on lot and lot of data, doing multiple rounds of data collection, this targeted data will help us hit the next level in accuracy much more faster and at much lesser cost. Yeah, I think that is done. Here you can stop sharing. So ultimately, uh, all the participants, I would like you to leave with this one line that it may be powered by cloud and deep learning and all the deep tech, but the fundamental reason the edge of Qualitas EagleEye Cloud is easy solutioning of machine vision system. No matter what technology goes back here, if it can reduce your project execution time by 50%, and that allows you to handle 50% of more projects, that is where when we succeed. Yeah. Thank you for giving me the opportunity to talk about this, Raghav. Please take over.